¿Empezamos ya? Hola.
Hello. Good afternoon. My name is Blanca and I work in Telefónica Innovation Department. In Telefónica, we always say that innovation is part of our DNA, and this is due to the fact that in everything we do, there's innovation. Probably you've seen that in our stand and in our everyday life. It's a reality. Telefónica will celebrate its 100th anniversary soon. In the past, we used to innovate only internally. We had a large department with a big budget, but a while ago we realized that innovating alone was not efficient, and we thought that we could accessorize our innovation with innovation coming from outside, startups, innovation, partners, innovation, and this is precisely what we would like to share with you. We have several open innovation initiatives. The most well-known one is called WIRA. Last year we marked our 10th WIRA anniversary. In Pavilion number 6, in the 4 years for now, we have a stand, an Aura stand. But there's also Open Theatre and Telefónica Ventures. In the last 10 years, we have invested in more than 1,000 companies. Today, we have 500 innovation companies in our portfolio, and many of them work in Grupo Telefónica or with Grupo Telefónica. Yobi is one of them. We partner with them in order to attract innovation, to attract talent, and use this talent and this innovation internally or bring it up or scale it up to our customers and thus helping them innovate. I am very happy to be able to share this project with you because we've been working together for 4 years. We met in an accelerator that we promote in Seville in collaboration with the local government of Andalusia. In the last 4 years, we have supported them, fine-tune the product, attract investors, and we have made ourselves available to partner with Telefónica, which is positive for them. Today, Yobi is commercialized through big accounts for many of our customers in Spain and abroad. Yobi has developed a disruptive technology. They have developed a device that you can see here, an eye called INESCUBE, which through AI cameras spot viruses and bacteria which are not detectable for human eye. This is then linked with artificial intelligence and neuronal networks and algorithms, and INESCUBE optimizes, as a result of that, many processes in the industry. They are now focused on agri-food and other sectors that they will tell us more about. To be honest, this technology can be implemented in many different verticals. For us, it's been a pleasure to partner with INESCUBE, with Yobi. I am sure that we will keep working together for 4 more years and even more. Without further ado, I would like to hand it over to Daniel Kumpel, CEO of Yobi, and Guillermo Bataller, Manager of Innovation in Telefónica, for them to tell you more about what this disruptive, groundbreaking technology is about and to share their plans for the future with you, as well as the main challenges that you face ahead. Thank you very much, Blanca. Thank you very much, Daniel. Would you like to start? Please go ahead. Thank you very much, Guillermo. Thank you, Blanca. Thank you, Telefónica, for the opportunity to share our technology at MWC. We are thrilled to contribute humbly to the digital transformation that the world is undergoing. Yobi is a startup that was born in the Open Future project by Telefónica. We are transforming projects and processes that had a path, and we have introduced a disruptive change, a radical change. The company, Yobi, focuses on problem solving through intelligent artificial vision. In order to solve a specific problem, we have developed a family of products called INESCUBEs. I have some of them with you. I have some samples with me. This is an INESCUBE, and this is the little son, the tiny INESCUBE. Both devices have what it takes to solve real problems in the real world. We are a company that places the customer at the center, and our goal is to understand our customer's problem. Before throwing an INESCUBE to our customer, we listen to the customer, the context problems, there are speed problems, vibration problems, temperature-related problems. There are many elements that need to be taken into account in order to fine-tune our solution, to personalize the solution to meet our customers' needs. In this support stage, we define the problem and we insert in a box called INESCUBE the necessary components to solve a specific problem. What is an INESCUBE? A camera with a sensor, lighting, the necessary hardware to process the image and the information produced by the camera, and the software, which is a compound of algorithms, not a linear program, but rather a compound of algorithms, some of them AI and others are traditional algorithms that are embedded within the system, within the INESCUBE's hardware, in order to solve a specific problem. We adapt the software to the specific problem. And oh, Daniel, let me interrupt you here. I'm not speaking. I forgot about you. I'm sorry. I'm going to answer to one of the questions that I was going to ask you. And the question was, what am I doing here? Well, I've been introduced by Blanca. I am the manager of innovation and transformation in Telefónica. And when the demos team saw your technology for the first time, we fell in love. And falling in love with innovation is key, is important. And we decided that you had a central place in the innovation center of Telefónica, and there you are. And here you are. Please, go ahead. Thank you. So, as I was telling you, algorithms, well, there's a flexible part of algorithms that are adaptable to a specific problems, but of course for that you need a training stage, like babies when they are trying to learn something from about the real world. So on the basis of examples such as pictures, images from the real world, we tell the artificial eye, this is that, or this is a healthy fig, this is a healthy nuts, this is an iron profile, this is an electric installation properly installed, this is a railway, a properly installed railway. Whatever you can think about, wherever there is an eye inspection, a human eye inspection process, can be replicated or transferred or taught to our artificial eye. After the training stage, we deal with outstanding cases or exceptional cases, such as, okay, this fig is contaminated, or this nut includes a toxic substance, or this is a smashed railway, etc. So we train the algorithm with positive and negative cases, and after a few weeks training period, which is also, by the way, automated, the system is ready to go to automatic mode, to production mode, and implement what it's learned without human intervention. The item the device is ready to take autonomous decisions. Daniel, let me interrupt you once again. I have another question. Why Telefónica? What does Telefónica contribute to the process? A lot. Without Telefónica, it would be rather difficult to be able to implement a project of this nature for several reasons. I think you're running out of voice, indeed. So oftentimes the software is embedded in the INESCUBE, but in the case of many industrial projects, it's necessary to have not only an eye, but several eyes in different spots. And these eyes are communicated one with another via 5G and Edge and Telefónica Cloud. In the Telefónica Cloud, you can perform the data analytics, the process analytics that allows us to consider what each eye sees and take decisions at a different level. So it's a perfect combination. From our perspective, from our side, from Telefónica side, we would like to say that many of the demonstrations that we are sharing with you in this stand, robotics, the 5G, WATA, well, one of the messages that we want to convey is that connectivity and the edge computing connectivity that allows for very low latencies are the features that allow us to convert human capabilities into automatic processes. Indeed, this eye, which weighs a few grams, can be integrated in a drone, in a robot, in a tractor. It can be on top of a transport pipeline. But of course, if you attach it to a robot or insert it in a robot, you can find the solutions at a different level, at a higher level. I have more questions for you, Daniel. Feel free. So, in this slide, we introduce a simple learning process to discriminate pieces of fruit. So if tomorrow we come up with an improved algorithm that allows me to detect more issues with the same hardware, we can disseminate it through Telefónica's cloud, and it reaches the eyes, right? Indeed, once an IOB technology has been implemented in Telefónica's cloud, if you need to solve another problem within a family of problems, you need to update the technology. You just need to adapt the software in real time. It's like a algorithms bookshelf with different neuronal networks, while you have to download in the edge the relevant algorithm in order to update the eye's capacity to solve a problem. Oh, that one is a good one. For who? Who for? A journalist was quite surprised about the capability of the robotic eyes. Who can we reach with this technology? It's a horizontal technology, like Telefónica. Today, all processes are communicated. Where do we stand today? Well, we're trying and transform the industrial sector. We are heading towards the 4.0 industry, allowing the industry to improve the quality of certain processes and come up with better quality products. In the agri-food sector, it's key to improve the quality of food products, and at the same time, there's a clear need to make sure that food is not contaminated. Public administrations impose thorough controls for food security. Does this technology make Spain more competitive? Indeed, of course. There are markets, producers, for example, in the case of nuts. IOB, in a Spanish consortium with Spanish funds promoted by the Ministry of Agriculture, has contributed to eradicating the problem of bitter nuts. Who likes bitter nuts? No one. It's good for for desserts, but a bitter nut looks like a sweet nut, but it includes amygdalin, which is a chemical substance that, when you bite them and chew them and produce saliva, well, it turns into cyanure. So a bitter nut includes a little dose of cyanure. Of course, it's not deadly. You would have to eat 500 tons of bitter nuts, but it's a toxic product and it's bitter. So the international market of nuts producers are penalized because they cannot spot or differentiate between a sweet or a sour nut. So now in real time we can detect bitter nuts in real time. 5,000 kilos of nuts, a big pile of nuts. With an artificial eye we can identify the sour nuts containing amygdalin. And the eye not only identifies bitter nuts, the eye includes a hardware, as we said before. So it has an air injectors matrix that blow out the toxic nuts that do not comply with the quality criteria set up by the producer. So the bitter ones are blown out and the rest are kept in the line. Well, Telefónica contributes with the 5G connectivity in the framework of this project. So we are somehow solving the Go Wireless challenge. We are installing eyes in different points of the quality control pipeline without having to wire the factories. Then cherries. Give us more cases, not necessarily cherry, not necessarily in the agro-food sector. People flow management, facial recognition. For example, let's say someone is in a line to access a cathedral, and at a given time there is an agglomeration in one door and the other door is empty. Thanks to facial recognition, theaters, and biometric recognition theaters, you can somehow facilitate things, right? In logistics, logistics, there's no doubt about it. There's an example that we'll tell you more about in a few seconds. In the manufacture pipelines and in the, well, there's a lot to be improved in these areas. Please go ahead. INESCUBE, well, the solution, the IOB solution, aims at improving processes, improving quality, improving human health, avoiding the ingestion of contaminated products, or carrying out. Could this be attached to blockchain? Indeed. They are accessories in order to ensure the value chain, indeed. These solutions promote sustainability, environmental sustainability, when, for example, controlling a fishery. If we detect a pathogen or a plague attacking a fishery, so we save time and we improve the quality of products, not only in the field, when we detect that a pollutant or a plague will attack tomatoes or oranges, such as the black fly. Well, we can anticipate this, and of course, because if the plague destroys the plant, farmers need to launch more pesticides. So it's a sustainability-friendly, it's an environmentally sound product. The main advantages of machine learning and artificial intelligence is that solutions are not closed. If we have new examples, new images, well, the system can keep improving. So tolerance and the precision that the final customer demands can be improved, and quality can enter a long life improvement logics. It's a permanent improvement scheme, and this is quite revolutionary compared to traditional IT. And all this is based on a neuronal architecture, right? Today we're going to be focusing on two business cases that have been implemented together with Telefónica INESCUBE PROTECT. We have here a demonstrator at a small scale compared to an industrial implementation. We'll see a clip later about the industrial implementation, and we'll see also an APP developed by Telefónica and IOBI that is implemented in logistics and which is absolutely disruptive. I use the word disruptive in the sense that it had never been done and no one would ever imagine this could be done. That's what we call disruptive today. Not just a little change, image change. Okay, so we're referring here to a revolutionary new product. Indeed. Here what we can do is use hyperspectral technology. Hyperspectrum goes beyond what's visible, infrared and beyond. So a wave is frequency and length. So when hyperspectral technology, which is not visible but is close to visible spectrum, penetrates matter, this provides us with information about the interior of matter. When you see this white flow, well, you see it white because you receive the light reflecting on the floor, and your eye, combining primary colors, decides it's white. In the hyperspectral environment, well, we cannot see certain frequencies as humans, but artificial eyes do or can, and thus obtain information about the interior of the product. So, for example, a cherry that has been hit by a stone, which looks exactly the same to a fresh one to the human eye, well, can be discarded by an hyperspectral vision INESCUBE, because the INESCUBE penetrates the cherry and it concludes that the texture inside has been disrupted, or rather damaged. Not disrupted, damaged. Can we see a demo? Of course. What do we have here? Tell me more about it, Daniel. What is this? This is a healthy fig. This is a rotten fig, which is with a toxic product. And of course, if you mix them, the whole package will rot very soon. And you cannot differentiate them with a human eye. So what do they do now? They take a sample of figs, they bring it to a lab, they smash them, they introduce reactives, and then they decide whether the product is positive or negative in axatoxin. Whereas if you have this enhanced vision, without having to touch the product, we can diagnose whether it's contaminated or not, comparing the frequencies of the contaminated fig with the non-contaminated fig. And I believe that in the food industry, this will be extremely interesting. This is a stone here, and this stone can be confused with a fig for human eye. The other day, we met with olive producers with nut, with no nut. Sometimes the stone can be confused with a fig, whereas when you use hyperspectral vision, it's much easier to discriminate between a stone or a fig or a rotten fig and a healthy fig. Let's introduce these three samples in the INESCUBE. We have the camera in front of the INESCUBE and the HDM camera. So what we can see here is the healthy fig, the contaminated fig, and the stone. We can see the 3 samples in the screen. This is only a demo. Well, for me, it's more than enough. It works. And in fact, the other day, a company asked me whether we can use this to detect contamination in water. Yeah, of course. The spectrum going through the water, the decomposition of frequencies, provides us with information about the pollutants. So, in a fig cooperative or in a fruit cooperative, we have a clip that we would like to share with you. Let's go back to the presentation. Yeah, here we have an image of a producer factory. This machine processes 2,000 fig kilos an hour, and this is a small one. Sometimes we work with machines that process 5,000 kilos an hour, or in the case of olives, 20,000 tons an hour. It's just a green spot going through. Whereas in fact, thanks to our camera, we can see fig by fig. We can differentiate fig by fig, and here come the figs that have been blown out or discarded, and the good ones that are being thrown to the good ones. We're running short of time. Can we have one last business case? Yeah, let's focus now on logistics. This has been a quite revolutionary example. In collaboration with Telefónica, we have been capable of convincing a we have convinced a German company to hire us. Yeah. First meetings with Jordi and Thomas. Customers were rather skeptical regarding us having the possibility of solving the problem, whereas we proved, thanks to our pilot project and our technology, that we are capable of doing what we say we do. Here we have launched the clip. Perhaps it will be more illustrative. So we have set up here an arch with several cameras. 2D cameras, OCRs, that read labels, like the one I have here at hand, and 2D cameras that read the volumes, that reproduce volumes. So when the machine passes through, the forklift passes through with a load, well, the system does not start, right? So what does the artificial intelligence define? Well, first, whether there's a freight or not. I really like this side, this part. It reproduces the pallet volume. It inscribes it in a geometrical cube that optimizes freight on board trucks, and it reads the label wherever it is. A pallet is 3 by 3 covered in plastic, etc. And the pallet oftentimes is covered by plastic, it has an irregular shape, etc. So the label can be anywhere, in any side of the pallet. So the problem of having to read a label that might be 3 meters away from the camera is, well, a big challenge. Whereas in our case, we can do it in real time. So the driver, while driving through the arch, obtains information about the destination of his freight. We decode the label and tell him to bring the freight wherever it's requested.
Porque quiero dar una noticia, o sea que me tienes que dejar un minuto, tienes que...
You need to conclude because I need a minute. Yeah, I'm about to conclude. So, while something will join us here. Oh, there we go, the robot. Do you know who that is? I know, this is another one that we are controlling via 5G. I'm a little bit scared when I see this. So we have some data here. I'm going to give you information here. So let's conclude by saying that the 2 business cases that we've shared, these business cases for the logistic domain. Measuring volume of big pallets can be implemented in different scenarios with different freights, and not only for logistics, but also in all the packaging business, requiring of a real-time identification of volumes and labels. So thank you very much, Guillermo. We need to close, but first we need to give Daniel and his team a big applause. Big applause for Daniel and all his team.
Gracias a la innovación.
Thank you. Oh, thanks rather to innovation, we all grow. Thanks for being here. And I'm going to give you some figures. Some statistics that I already shared with you yesterday. Come back to me. Don't leave. You're responsible of this. So yesterday we had 1,825 demonstrations. Today, even more so. So all in all, 3,000 demonstrations in 2 days. And I haven't counted these ones. 3,000 demonstrations in a few days. So 12,000 people walked past Telefónica stand. Yesterday, 2,000, so more and more people are visiting us. The bartender has served 1,103 glasses of wine. It takes the bartender 35 seconds to serve a glass of wine. And smart industry, 302, the demos. Of course, it's a much more complex demonstration. It lasts a little bit longer. Home, 132, and spot circulated for 3 hours and a half. An extra half an hour. So, thank you very much.
Gracias.
Enhorabuena.
Muchas gracias.